Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be sort of a tutorial and a review of what we talked about in class on Thursday evening. There is, and deservedly so, there is quite a bit of confusion around Lab 10.2. And this is actually going to sort of mirror the final exam topology. And so I want to make sure that we're all clear on exactly what's going on here, because you can see we've got VRF VPN-A on the left, we've got VRF VPN-B on the right, both hanging off of router 2. We've got this overarching global space that this drawing kind of gives the impression that the VRFs are inside the global rib or the global routing table space. And then what caused a little more confusion was we have router 3 with a serial connection, appears to be a serial connection over here to router 2, but we can see that it's a sub-interface, right? And that is also a sub-interface, and this connection here is a sub-interface. But again, remember, this back-to-back serial connection right here, we know that on the routers it's serial 0, 0, 1. That is the parent interface, right? And then under that parent interface, we can create sub-interfaces. But we have to use frame relay to do that. To do these point-to-point frame relay sub-interfaces, we have to use frame relay. Or to do point-to-point sub-interfaces, we have to use frame relay. It won't work with HDLC, like we demonstrated on Thursday night, and it doesn't work with PPP. So frame relay is what's going to allow us to do this. Now, again, remember, the reason that we're able to create these VRFs is because we're creating sort of a virtual router inside of router 2 for VRF VPN-A and VRF VPN-B. But this representation here, this is not a new serial link over here to the right. It's the same physical cable. It's just that what's being done, they're actually doing what's called back-to-back frame relay. I'm doing some other recording right now, and interestingly enough, this came into play talking about OSPF network types and trying to emulate and demonstrate a non-broadcast multi-access segment, which the main the main serial or frame relay main interfaces will default to NBMA. So you can use the main interface, right? But what I'm going to demonstrate here between router 1 and router 2 in my lab is how we arrive at this configuration here. Specifically, we're going to kind of focus over here on this side, because if you understand what's going on over here, you'll easily understand the exact same thing takes place between router 1 and router 2 over here on the left. So again, we've taken the main single physical connection between router 2 and router 3. It's a back-to-back serial connection on interface serial 001. And what we're going to do is we're going to change the encapsulation from the default HDLC. We're going to change it to frame relay. And then from there, it's actually very simple, very straightforward to get us to the configuration where we can do sub-interfaces. And that's the interface that this VRF sits in. And again, you might be asking, well, I don't understand, why did they create this VRF out here under this sub-interface? And it's basically so that router 2 can pretend, right, that we have this autonomous system 65503 out here. And then we have another BGP AS 65002. And so we're using VRFs on router 2 in addition to these back-to-back frame relay sub-interfaces to sort of segregate these BGP peerings that will be between router 1 and router 2, but in the VRFs, we're segregating them from the global table, right? In this drawing, it kind of shows that everything is in the global table. Well, remember, the VRFs are not in the global table. And again, that box here is kind of causes a little confusion, making you think that, oh, so these are all in the global rib. No. We've got a VRF for VPN-A and a VRF for VPN-B. So let's go ahead. Let's get on the command line. I'll leave this up. We'll come back to the diagram, obviously. But let's walk through the very simple steps. And again, this is a great way to sort of maximize a single serial interface connection in a lab environment if you were looking to do something like, oh, I want to create VRFs and then have peerings in the VRFs stand up or be stood up. So let's go ahead, get onto the command line and work through exactly what we're seeing there in the drawing. So I'm on router 1 here, and we're going to be using serial 010. So let's go from user exec to privilege exec, say show IP interface brief. And this is the interface that we're going to be using. Again, it is directly connected via just a back-to-back serial cable to router 2. So if we get into global config and I go into interface serial 010, remember, the default encapsulation for Cisco serial interfaces is Cisco's secret sauce, Cisco's HDLC, right? Most people just say HDLC, but sometimes you'll hear CHDLC. So again, sorry about that. So again, we've got HDLC as our layer 2 encapsulation. The other one I could say encap PPP, right? For point-to-point protocol. However, if I do an encap with a question mark, you can see we've got quite a few choices here, and one of those choices just happens to be frame relay. So I can change the encapsulation on the interface to frame relay. Now, what's interesting with back-to-back frame relay is, remember, there is no need for LMI, right? That link management interface. There's no need for LMI keep alives. So you can turn them on, right? But there's no need because there is no frame relay switch or that, that ubiquitous cloud that sits in between the routers. It's not there, right? We are directly connected. So I can say no keep alive, right? And by saying no keep alive, I'm basically saying no LMI, right? Because it's LMI that's sending those keep alives. So we can turn that off, right? I've already done the no shut on the interface. And so in the parent interface, do show run interface serial 010, on the parent interface, that's all that's required. Because now I can create literally hundreds of sub-interfaces off of this one parent interface, all leveraging frame relay as the encapsulation method. Now remember what I said. What you're going to see me do here, these point-to-point sub-interfaces, you cannot do this with HDLC, and you cannot do this with PPP. Right? So in fact, let's see, router 7 here is also connected with a serial link. And so let's cover that real quickly. I've got these EEM scripts here. So real quickly, we're going to say do show IP interface brief, and we will use serial 010. We'll use serial 010. So I'm going to say default interface serial 010. If I go into interface serial 010 and I say encap, we'll use PPP first. I say encap PPP, right? We'll say no shut. And then I say interface serial 010.2, right? To create a sub interface. You can see that we get this error here that says it doesn't recognize the interface. But if I do that, I get into the interface. So, but when I say interface serial 010.2, we get this error message. Now, let's come over here to where we've got the frame relay encapsulation on. What happens when I say interface not frame relay, sorry, interface serial 010, and actually we'll pull it back, 010 dot, and it's between router 1 and router 2, so we'll say dot 12, and I hit enter. It says incomplete command. So what else could it be looking for out here? Well, again, it wants me to tell it what kind of a frame relay relationship am I going to have on this subinterface. Is it going to be a multi-point link or a point-to-point link? And remember, we are talking about point-to-point links. So when I say interface serial 010.12 point-to-point, it drops me into that point-to-point subinterface. Again, back over here, when I said interface serial 010.12, and I'll do a question mark, you can see that it's an unrecognized command because the PPP encapsulation isn't going to support it. If I went back into serial 010 and I said incap frame relay, and then came back and said interface serial 010.12, oh, sorry, you get the incomplete command because, again, we have to pick, is it going to be point-to-point or point-to-multipoint? So you can clearly see that there is a significant difference, right? So the frame relay encapsulation is what is required. But again, super straightforward. So we create our subinterface, and now this is where, just like if I was on Ethernet, and I was creating an Ethernet subinterface, right? Typically, what do we have to do right away? Before I can put the IP address in on an Ethernet subinterface, and let's take a look at that. So if I'm on, let's pick a different router here. So if I'm on router 4, and I go into interface, and let's do a default interface on FA00. Right, so it's set to the default configuration. If I say interface fast Ethernet 00.20, and I hit enter, you can see it puts me into the subinterface. If I try to put the IP on here, and I'm going to drawing a correlation between the similarities here. So if I said IP address 1.1.1.1, and then we'll just do a 255/24, we get this error, right? And it tells us, hey, I appreciate that you're trying to do a subinterface on the router, but I need to know the 802.1q tag that I would be expecting to see coming in off the Ethernet switch. Because remember, router on a stick, which is kind of what we're doing here with the subinterfaces, the router on the stick approach is there's a VLAN that I'm going to be plugged into, or a trunk that's going to have multiple VLANs coming to me, and I need to know how I'm going to service that, right? What subinterface is that traffic destined to? And so it's not that far of a stretch to draw and compare and contrast here. So with the frame relay, it's not that the IP address, so we'll put on here 192.168.12.1. So it's not that it won't take the IP address, right? That's not the similarity I'm trying to draw. The similarity I'm trying to draw is now we need to say frame relay interface DELC, that data link connection identifier. And now remember, in a sort of realistic frame relay environment, you've got the DELCs, which are locally significant, but then again, that's how the traffic is being switched, right? Off that frame relay interface DELC. And so in a back-to-back frame relay configuration, because I can have over that single physical link, right? Over this single physical link here, I can create a crazy number of sub-interfaces over this single physical link. And so between these two routers, just like when we're doing router on a stick, right, where you've got your router and it goes down into a switch, and the switch has a trunk port here, and we've got all these different VLANs coming up over this single physical link. When they arrive at the router looks at it when it gets to the FA00, and it says, okay, I've got sub interfaces here. How do I know which sub interface this traffic is going to? And over here, we do that incap.1q, and then typically we put the VLAN number that matches the VLAN, right? So we're using .1q over here. Over here, we're using the DELC. Because if you don't match the DELCs on the sub interfaces, it will not bring the link up. The delcies have to match, and that no keep alive command has to be there or it won't work. And to clarify, the no keep alive command, if you're not going to set LMI up, the no keep alive must be added. If you're going to set LMI up, and again, there's no reason to set LMI up because again, it's back to back. There is no switch in the middle where we need to have keep alives being sent to. So again, router on a stick, it's .1Q, right? But over here, it's the delcy value. And so let's transition back to our config. So we say frame relay interface delcy. Now the first 16 are reserved 0 through 16. So we can use, or sorry, 0 through 15. So we can use 16 to 1007. So it's between router 1 and router 2. So we're going to say 12, right? So frame relay interface delcy 12. Whoops, sorry. And we need, I'm missing something. Oh, we can't use 12. I just said you can't use 0 to 15, and then I tried to use 12. So instead, let's use 21. How about that? Better value. All right. So that's it. That's everything. So let's take a look. Do show run, and let's begin at serial 0. Oops, sorry, 0. Yeah, we're 1010. And is it looking for? I think it's going to be spelled out. There we go. All right, so here is the configuration as it stands right now. And if you think about it, right, we've got the main interface here where we put encapsulation frame relay. We said no LMIs, right? So no LMIs. We don't need them. It's back-to-back frame relay. We create our point-to-point frame relay subinterface. We put an IP address on it. And then we do our incap.1q VLAN number, right? Just like we do, and we've done many, many times with router on a stick, right? We put frame relay interface delcy 21. All right, so now let's go ahead, let's transition over to router 2, and let's bring this link up. Let me clear the screen here. Let's bring this link up. We'll get over onto router 2. And let's go from user exec to privilege exec into global config, interface serial 010. And we're going to say no shut, no keep alives, right? No LMI messages required, incap, frame relay. And now that's it for the parent interface. We're done. So now let's jump into interface serial 010 dot, and I think we used, and this value does not have to match, but you'd be crazy not to match it if you ended up having to troubleshoot. So I'll say serial 010.12, but before I hit enter, I need to do what? I need to say point to point, right? Because again, we're doing point-to-point sub interfaces. So now that I'm in the sub interface, I can put the IP address on here. We said 192.168.12.2, and we're going to do a /24. And now I get to do my incap.1q VLAN command, right? So again, but for frame relay. So frame relay, interface delcy, and we used 21. All right. So we haven't seen anything say it's going to come up or down yet. And let's make sure do show IP interface brief. I think I did a no shut up there, and we did. So let's kick our ping off. Do ping 192.168.12.1, and we'll repeat it just a few times there. And take a look at that. Right? So I've got connectivity between these two point-to-point sub interfaces via the frame relay layer 2 encapsulation method. And again, to draw us back to this image here, that's exactly what is being done on that physical connection and that physical connection. So now let's take it one step further. Let's incorporate the VRFs in, right? Because we're kind of simulating what's going on over here. In fact, we'll do this. Let's create a second sub interface, right? Because the second sub interface here is going to be in the global rib. It's not VRF'd off, right? There is no VRF on that sub interface, serial 001.2, but there is a VRF on 001.1. And so we're using 12, and for this next one we'll use 1122, or we'll use some different value, maybe 99, something to definitely differentiate it from what we're seeing here. So back onto the command line. We know we've got our connectivity, so let's go ahead and do another subinterface. So we'll get out of this subinterface. I'm going to say interface serial 010 dot, and I'll just say 99. And again, this is going to be a point-to-point subinterface. So we'll use IP address, and let's do 172.16, and actually we'll use 99 as that internet. We'll VRF off 99 as the internet VRF. So we'll say IP address 192.0.2.2, and we'll make it a /24. And then we'll say frame relay interface. Didn't like that. Frame relay interface delcy, and we'll use 99. Right? Now let's come over and actually we'll kick a ping off here. So do ping 192.0.2.1, and we'll repeat this any number of times. Right? Now it's going to fail, right? Because we haven't created the point-to-point sub interface on router 1 for what is eventually going to be our, we'll say INET A VRF for Internet A. So here we are over on router 1, and let me back out here. We're going to say interface serial 010.99. Remember, the sub-interface number does not need to match between the two routers. The interface delcy value does. And again, similar to router on a stick, right? When I create my sub-interface, there's nothing that says that for VLAN 10 in a router on a stick configuration that I have to say gig 00.10. I could say gig 00.54. But again, when you go back to troubleshoot something like that, I wish you the best of luck. So we're doing point-to-point sub-interfaces here, and IP address is going to be 192.0.2.1, and we'll do a /24 to keep it simple. And you'll notice, do we have connectivity right now? We don't. Why do we not have connectivity? So here's where you could do a spot the differences. Take a look at how I configured that interface. Whoops, how I configured this interface. That's right. We don't have, see, it's not going to work without the frame relay interface delcy command being on there. So let's go ahead and say frame relay interface delcy 99. So as soon as I hit enter, we're going to jump back over here to router 2 and take a look at that, right? Because we've got that layer 2 encapsulation. So the traffic, again, the traffic is all physically transiting this single physical serial cable, right? But we're carving that up into multiple sub-interfaces. So we'll say that this one here is going to be our delcy 12, right? So we'll leave that in the global table. But 99, I like that one. I like 99 for our INET, and we'll just call it INET A. We're going to do a single VRF here. Because now what I'm going to do is I'm going to create a virtual router 2. Just think of like VMware, right? And you have a physical server. And if you're running VMware on that server, you can spin up multiple virtual servers. So you can have server A, server B, server C, and they're all running on a single physical box. And the same is true with VRFs and Cisco routers. I can create individual virtual routers, just like I create virtual machines in VMware, and I'm creating those on this physical Cisco router, and they're all going to reside on this physical router, but they're independent of each other in terms of the information that they contain and what they can see. So let's go ahead and we're going to use that 99 as our sub-interface, right? So we're going to use 99. And we'll create a VRF here real quickly. All right, so the first thing we need is we need a VRF. And what happened here? Okay, this is still going. So I'll do the VRF over here first, and we'll let that wrap up. So I'm going to say VRF definition. And again, this is the name of the VRF. And I'm just going to call it INET A. So, because again, we're sort of representing, I'm sorry, I'm on the wrong router. I thought it was bounced back to the wrong router. Let me come back over here to router 2, and I'm just going to kill this. All right, so we're going to say VRF definition inet A. And that's going to create the VRF for us, right? Now, we need a route distinguisher value here, and it's not that it's going to be used. Oh, actually, we'll just use 99:99, right? And since I'm using the new form of the VRF creation, I need to say address family IP. And before I do that, if I said do show VRF, right, you can see protocols. It's not going to work for any protocols. I have to say address family IPv4 and hit enter. Now if I rerun do show VRF, the VRF can forward IPv4, right? So there's the creation of the VRF. Now what happens next? Well, I pick the sub interface which I want to put into the VRF. So which sub interface did we say it was going to be? So do show run begin serial 010. We said it was going to be 99. So this is the sub interface that I'm basically going to carve out of router 2 and make it its own little virtual router that runs on router 2 but that doesn't share any of the routing information with the rest of router 2. And so let's go ahead and go into interface serial 010.99, and I didn't want that, we wanted 99. So we're in interface serial 010.99, where I'm simply going to say VRF forwarding, and we're going to get a message here telling us that the IP address is going to be removed from the interface, right? So you can see IPv4 disabled, but that's okay. That's why we displayed it here. So I say copy and paste, and we put the IP address back on. If I were to pull back that do show run command, where we begin with serial 000, you can see that there is my interface, serial 010.99 on router 2, right? So I've created like a virtual router on router 2 to which the sub interface, serial 010.99, belongs, and router 3's serial 010.99, router 1's, do we still have connectivity? So I'm going to come to router 1 first for a reason. I say ping 192.0.2.2. All right, it works. Great. So we rush over here to router 2, and we'll get into privilege exec, and I say ping 192.0.2.1, and I hit enter. And it doesn't work. Why is this not working? Because if I can ping from router 1 without any issue, why can I not ping from router 2 to router 1? Exactly, because we've placed the sub interface with that subnet on it into a VRF. So if I was to say show IP route, where is the connected interface for 192.0.2? It doesn't exist. In other words, it's not here in the global rib. Remember, the VRF was created on router 2. If we go back to the drawing, we're creating the VRFs on router 2. You'll notice there are no VRFs on router 1 or 3. And there don't need to be, because this connection over here between 3 and 2 that we see on the right-hand side that can be tricky when looking at thinking, oh, I need another serial cable. No, you don't, right? It's a sub interface that we're not putting into the VRF. We're putting this pseudo BGP AS peering into the VRF up here off of router 2, or I should say inside of router 2 is a virtual router, a virtual routing and forwarding instance. And it's over that VRF peering, right, or over this VRF'd off interface on router 2 that 3 will be establishing a BGP peering. You can see here we're doing eBGP here. The iBGP is running between 1 and 3. And so this was the line that I kind of drew in class on Thursday, is if you look at it like this, right, and this is the internet here, right, and this could be our service provider. We have 2 front door routers for our enterprise, and they both connect into the different service providers via eBGP. And that's what the VRF is facilitating, allowing us to sort of pretend that we're connected to BGP AS 65503 and 65502. So let's go ahead and finish this up here by saying, what if I said show IP show IP route VRF INET A on router 2. Aha! There's the interface. But to see it, I had to specify the VRF. Remember, it's got its own mutually exclusive routing information, right? That the global rib doesn't see this information, and you can see this VRF rib doesn't see anything that was in the global table. So that is how you create a VRF. This is how you see what we've got going on in terms of routing information. And so now let's go ahead and do our BGP configuration and what it would look like. So I'll treat our router 2 here as if it was AS 65503. So we'll go into global config. And we're going to say router BGP 65503, right? We'll go say BGP log neighbor changes, and I'll put my neighbor statement in. And again, I'm sorry, we won't, got to remember, so we've got this VRF, right? So I can't put thinking we're on router 1, so again, I can't just simply say neighbor 192.0.2.1, remote AS, and I'm not even sure what, we'll just say it's 65001. So if I were to do that, right, and then let's come over here to router 1. If I get on router 1, I go into global config, I say router BGP 65001, and I put my BGP log neighbor changes, and then I say neighbor 192.0.2.1, I'm sorry, 2.2, remote AS 65503. And I hit enter. And we're waiting, right? So I'm waiting for this adjacency to come up. And if I were to say do show IP BGP summary, you're going to see that we're idle. What about over here on router 2? If I were to say do show IP BGP summary, are we idle? It shows that we're idle. But here's the problem. This is never going to come up. And the reason it's not going to come up is, again, remember, we've placed it into a VRF on router 2. So on the router 1 side, we don't need to do what I'm about to do, but on the router 2 side, BGP is VRF aware. And we have to treat this peering on router 2, we have to put it into a BGP aware VRF peering section, because we don't want it to be part of the global BGP section. And that's what this command is doing right now, right? This is looking in the global rib for a neighbor 192.0.2.1 and trying to get to that neighbor, and it's not going to happen. So let's go ahead and let's say no, and let's pop this neighbor statement off here. And let's put in address family IPv4 VRF INET A, right? And so I'm now creating a BGP VRF aware configuration section for the connection from router 2 to router 1, which on 2 is in the VRF. And it's here where I would end up saying neighbor 192.0.2.1, and the remote AS is 65001. And let's go ahead, and I'm going to probably end up, well, I won't change it, and we'll say activate, right? So I've put the neighbor statement into the VRF, and take a look at that, right? So now if I say do show IP BGP summary, what do you think we're going to see? Am I going to see idle? Am I going to see that the prefixes exchanged is 0? Because again, we haven't exchanged any NLRI. Or will I see what we just saw, which is nothing? Yeah, we're going to see nothing, because when I say do show IP BGP summary, it's looking for BGP information from the global table. We have placed this peering into VRF INET A. Again, on router 1, no VRF required, so when I come down here, the peering is up. It's been up for 41 seconds, right? But we treat it differently on router 2 because it's in a VRF. So how do I see that? Do show BGP IPv4, and actually I'm going to have to go down. I think it's IPv4 VRF or VRF. Let's get down to here. So show BGP, and is it VRF all? Yeah, VRF or asterisk, sorry. VRF asterisk all, and what am I looking for? Summary? No. Show BGP VRF, and we'll do INET A as I think what I'm looking for. INET A all, there we go, and then summary. All right. So even when I run my BGP command to check on the routing information in this VRF, I have to specify show BGP, right? Show me the BGP information for the virtual routing and forwarding instance INET A, right? And give me the summary. So instead of saying show IP-BGP summary, which is going to give me nothing, I have to specify the VRF name because it's in the VRF. And the same is true if I go into, let's say, interface loopback 99, IP address 99.99.99.99, and we'll make it a 32/32, right? If I go into router BGP 65.503, and I go into address family IPv4, not unicast, sorry, IPv4 VRF INET A, and I put the network statement in here because that's where it has to go, and I say 99.99.99.99 with a mask of all 255s, and I hit enter, am I going to see anything over here? Right? I've just advertised it, so if I was to say do show IP-BGP summary, how come I don't have any prefixes received? How come I see no NLRI here? Whoops, sorry. Let's get that command out of there. How come I see no NLRI here? I should see it. And it's not because I didn't refresh or do a soft reconfiguration inbound or outbound or brought the peering down and brought the peering back up. The answer is that, again, remember, the interface can only be in a single VRF at a time. And so this loopback interface, I would need to say VRF forwarding, I'm sorry, get out of here, let's go interface loopback 99. I would have to say VRF forwarding INET A to put the interface into the VRF. And again, we lose the address information, but not a problem. We know that it is, oh, whoops, that's the wrong command. We know that it is teed up here, right there. Right, so now when I say do show run interface loopback 99, the loopback is in the VRF, right? Because again, we can't have it showing up in the global table. It's in the VRF. So now when I come over to router 1 and I say do show IP-BGP, now it's able to be advertised to router 1 because it's been placed into the VRF. And so again, all we've done is we've carved up router 2 so that we're able to do a BGP peering between, in our case it was 1 and 2, but here between 3 and 2 over this point-to-point frame relay sub-interface, leveraging that physical serial 001 cable, and it's in the global table here on 3, and that's fine, that's what we want, but up here on 2, we want it to pretend to be multiple autonomous system numbers, so therefore, what have we done? We simply created 2 virtual routing and forwarding instances that facilitate that. And again, with these serial links, we could not do the point-to-point sub-interfaces with HDLC. We could not do those point-to-point sub-interfaces with PPP. It does not work. But with frame relay, we end up with behavior strikingly similar to the router on a stick. And instead of saying incap.1q10 or incap.1q99, we're saying frame relay interface, delcy, and matching the delcy numbers on the sub interfaces, right? And that is what allows us to do those point-to-point sub interfaces. And again, this connectivity over here on this side of the screen, this is another frame relay point-to-point interface, but what was the significant difference between router 2 and router 3 on this connection here and this connection here? Exactly. Here, there is no VRF. So on both router 2 and router 3, all of this information is going to show up in the global rib. Okay, so again, quick review. Back-to-back frame relay is what is allowing us to create these sub-interfaces, which are point-to-point sub-interfaces. And it's via these point-to-point sub-interfaces that we can then take them individually, throw them into a VRF, and then that routing information on router 2 is segregated from the global rib. And again, that's why I'm not a fan of this box here. It kind of gives the impression, I guess, just from looking at the global statement here, that these are underneath the global rib. They're not, right? They are their own independent, mutually exclusive routing tables with their own routing information. And that is how Lab 10.2 and subsequently the final exam are going to be configured, right? So if you haven't brushed up on your BGP commands, and I'm definitely guilty of that myself, as you saw, right? Be ready for those show BGP, VRF, INET, whatever, or VPN_A, VPN_B, right, in order to see that BGP information up here on router 2. All right. Well, hopefully this has clarified exactly what this diagram is representing, and not only what it's representing, but how, from a configuration perspective, using a single physical serial cable, we're able to come up with this configuration. All right, guys, thanks so much for watching, and I will see you on Thursday night.